So, my dog is trying to get me to play with him. I'm going to record this quite quickly. This is a toroidal shape, alright? Which, imagine that immediately in your head and just know what it is. Because I'm not going to fucking give it to you. Anyway, take one side and take another side. You're going to match them with a slight overhang in between, kind of like monkey hands, okay? But then put wave bumps there, alright? As they slide through each other, they create a degree of compression in incredibly close tolerances. Alright, that's going to be also where your spark gap is. Anyways, it expands, they counter rotate. Two of those toroidals have a bunch of spokes, effectively, or plates, whatever, I don't care. To me, I ended up using a central fan which isn't really a fan, but they're a bunch of spoke blades that suck in air, and then centripetal forces, because curvature, hollowness goes out to where those ultimately suck in and then throw in, kind of like a carburetor, but I don't need a carburetor because then you can put a manifold, which is your fuel rail, as another toroidal that fuel injection, and then it's sucking in air. It's a port injection, you know what I mean? Or you can put the direct into the toroidal itself fuel there as an outside fuel rail, which gives it mechanical fuel pressure the faster it goes. And you can reduce the amount of overhead of a fuel pump as the engine will do it itself. And then you just need to do a upward and downward style movement for a sliding valve or something like that for a nozzle to throw it in as a direct injector. Or you can use both. All of that will work. And you'll take a larger part of the spoke area to a smaller part of the spoke area into a manifold that's inside of the toroidal donut that's sliding. Okay, so it's going to be on fluid bearings. You're going to want oil with, a piston ring of some kind style, where that way it can still maintain its pressure around the top and bottom of the toroidal shape, the donut shape that has. Hopefully, you have bearings in there too. You're going to want them in grooves, so that way you reduce the friction and pressure of this even more. So, anyways, pretty simple stuff. The spokes, of course, connected to a main axle. They rotate. They suck in air. They get close. That's your compression. Those are your compression ratios because they're statically fixed. Same as any other engine. Alright? It goes squeeze. Then you have spark. Bang. After its version of a sort of like a top dead center. And then, of course, combustion that expands both of the rings, the toroidal rings, producing torque. And then you have exhaust. Wherever you really kind of want it to go out, I usually use the top right. Yeah, or, well, if you were to look at it dead on, then it'd be towards the back. Okay, and then you can dynamically change both where it ignites, but also if you want a single, dual, or 4-stroke style. Because you can have my injectors with this level of speed and extra pressure you can start at. You can forcefully make air and fuel come together, spray in with ignition as a constant, one-stroke injector system that just bleeds out the right amount of exhaust and constantly uses that extra expansion that it's resisting against meaning, as an air spring, is it's a hot gas that it then compresses and then allows for it to expand, like that. Except, you know, the injector, of course, will add to it. So it's like if you compress a spring, it will then come back down, right, or out, or in, depending on the type of spring we're talking about. Same thing. Gas also does the same thing. Anyways, you don't have to do that. You can fully exhaust it, because of course you can play with your exhaust sizes and ports in lengths and duration. Anyways, two-stroke is of course standard two-stroke scavenge. You exhaust. You then suck in, and you add some fuel, squeeze it, shove up, standard two-stroke, but it acts like, because you have over here and over here a one-stroke, and then you have a four-stroke, standard four-stroke process. You can have multiple rings very close together, so long as you have a cooler, okay? You're still going to have that fluid, which is, in this instance, a low viscosity hydraulic fluid. I'm a big fan of lubricating hydraulic fluid. They are like primo. I love them because they're a real easy, cheap way to get lubrication and coolant to be cooled off into a radiator without needing that kind of stuff, because it won't freeze either in the cold nearly as well as long as you treat it well. But they're also something that you can combine. You can combine the hydraulic fluid with lubrication with an actual more liquid, like a water, type or antifreeze sort of combo, which you normally wouldn't want to do, but there are some that will actually combine, and then that's still something that is able to be cooled, but hydraulic fluid can also be cooled, so I don't really see why you'd do it, but whatever, and move off of that. But you can also have it go downwards, if you don't know. You see, that can be its own version of a structural exhaust manifold port system that goes into an axle area, if you so choose. I wouldn't, but that's me, because a center out is much easier to have that turning actually act as a compressor supercharger style. But of course, it's not totally like that, but whatever. The reason why I mentioned it is because it's like, well, you have this other turbine, but it's not technically speaking pistons. And I'm like, well, there aren't really easy ways to make a piston do this. You need counter-rotating pistons that are going to go real close to each other. And so, my counter-rotating turbine blade design is already there. And so it's that goes with a center little turbine that then sucks it into underneath, and then there's hollow blades above that, above the, or the shroud, housing of that turbine. It sucks it in from the rear and the front together to help act as a compressor, and then it goes through hollow, and then it goes in based upon as a up and down wave bump. It acts as its own version of a piston ring valve. So it's goes up, it opens, or well, in this instance, it goes down, it opens, and it goes up, it seals, and allows for that to then go as it rotates with these. You'd have to take your hands. You know how your hands can curve in. Well, in this instance, you'd be wanting it to really kind of go differently. So you'd want to have it do the opposite. So take two katanas that are curved towards each other or away from each other. Damn, that's a hard one to describe. So it's the one half of a crescent moon, like the fingernails. Anyways, take your fingernails. That's a better way to do it. Here's your thumbnails. So take your thumbnails, and then you're gonna have it from where your hands are, with the thumbnails facing your eyes, of course, because How else are you going to see him? Anyways, rotate them towards each other, and you'll see the edges come together. That creates a pocket of like compression, and then if you think about it as a z-axis, that's like cupping your hands with your fingers open. So it's like they'll come in, and then they'll pass through your fingers, and if you do that the right way, they'll compress in that area. That's ignition, and then as you can see with your fingernails as you rotate them, it then will have an open area pocket as they overlap. And as it goes upwards, because it travels upwards and out, and then that's an exhaust port, and that causes expansion. And so that acts as a big lever as it's trying to open it, but it only allows for a pumping action of opening area up to a specific area where the ports are. So it's like, this is basically a version of that, but now with donuts. Toroidals. Because their toroidals are done. I don't care what the hell they say. They're donuts. A donut can be any shape. That's got a hole in it. Yeah. Anyways, this one just allows for it to all be forcefully placed into a spoke kind of thing, and then you can just have that rotate on very low friction, bearings with complete balance and no need for any of it to do anything other than that. And it's like, well, have it come out the two sides. There's your equaling tube headers into like, here's a turbo. You already have a supercharger anyways, so it's like, here's a turbo. It'll reduce the parasitic loss of the supercharger part, and you can dynamically change that as you want. And then you'll be able to reduce your fuel pressure, during start, right? And that should run it perfectly, extrude it with an engine block and cooling. So, because it's like, oh, there's air here. It's like, well, I can put water there, or coolant, like hydraulic fluid that comes right off the radiator, so that'll cool it. Or like a secondary radiator for air to air, or water in this instance, hydraulic fluid, coolant, things, because I can just add in little stators, heat sinks on the internal diameter of it. And what do you know, that's also a place for me to shove in fuel as an injector, as an automatic mechanical system with some bump stops and a fuel rail as it goes, opens, plunges in as a bump stop, squirts it in. Pretty simple stuff to me, if I'm being honest. Cheap as fuck to make too. You can't mill a circle? What, you got ring gears, right? Well, yeah, we have ring gear. Okay. Look at you with your not having the ability to fucking, I don't know, mill some ring gears effectively the right way. Here, I'll just cast them. That's the treatment afterwards, some sanding and shit. Real cheap, easy manufacture. Bing, bada, boom. Baby! We're in business. There you go. Goes fast. It's like a turbine. It's not a turbine though. It's a toroidal engine. That's right. It's a real toroidal engine. Wait, what? It's a real toroidal engine. It has pistons. They're just connected. just gives you more torque anyways. That's correct. And they don't have to be very thick. You know what I mean? It's got to be thick in the right places. Hey, hey, hey! Anyways, that helps out. It's an old one. I haven't really worked on it because I worked with the turbine for a long time. So it's like, there you go. Engine. Engine better than most engines. Pretty fast, efficient, balanced. Not gonna wear out easily. Doesn't have the chunkada 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 chunkada. I hate these toroidals sometimes because it's like it goes boom and then it like has this harmonic imbalance and then it moves. So it's like over to the diagonal top right, and then it'll go to the next one diagonal top left, and then it'll go to the next one horizontal left, and then it just rotates like that, and it's like I dislike this. And it has this weird like I'll suddenly give you power, suddenly give you power, suddenly give you power, and I'm like no. Power all time. Here's 4 powers, power, like a freaking what's it called, crossplane, style of a crankshaft, and then here's a 2, like a screamer crankshaft, and then you have like a big bang screamer crankshaft, which is the 1 stroke. Bang, 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 bang. It's turning, bang, turning, bang, turning, but it slows down, but then it's still going, but then it's like, bang, but it's actually technically still going, because it then saved that, and so like you can bleed, and you can remove a certain amount of like extra air and fuel that you put in, and so it's like, well, it's conserved in the gas air spring that it now has a certain amount of energy, and as it expands, you can then, after top dead center, start the burn process. And so it's like bang, 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 that kind of thing. Anyways, alrighty, there it is. Bye.